Well, environmental mapping and GIS technologies. First of all, uh, I'm going to speak with you about fundamentals of geographic information systems. Uh, Maybe someone can uh, tell me about your understanding of what does uh, geographic information system means. Are there any volunteers experience? Hmm? Nobody wants? Anya, Anastasia?
Я?
Yeah.
О, вибачаюсь. Так?
We need to say about information about the Earth's surface, or what? Uh, what we need to say?
Uh, Tell me about your understanding of what does geographic information system means. Well, let's begin from
For me, it's like a system, kind of like which consists of some uh, geographical aspects like relief, like landscape, and it's all like in all the system.
and other Earth features. Yeah.
Yeah, yeah,
Well,
exactly.
uh, would you like to tell me examples that you probably know on the net, um, on your phones, on your smartphones that you use in everyday life?
Google Maps or Google Earth.
Well, uh, maybe someone use another map application.
No,
No, why?
Because we
because
don't
we
know
have.
about another.
I think that Google Maps it's a good add for me because I can to find every point of the map with this aid.
Well, probably you know about Bing Maps from Microsoft.
No,
You can find them on the net, and also Apple Maps for Apple devices.
no.
No. Another example, uh, speak about a huge volunteer project, OpenStreetMap. Uh, you can also find it on the net and join this initiative and to make some part of world map yourself. Well, I see. What GIS? What is it? We have no easy answer anymore because uh, probably we can explain this kind of information system as uh, software for digital maps presentation. Um, but this um, This is not um, all true because probably you can use not use for example Google Maps not for only for representation of the information but also for searching uh, some useful data uh, for finding a road from point A to point B and every GIS in my opinion it's kind of interface between you and spatial database. So we are speaking about uh, geographic or geospatial information about different places and features on the Earth surface. And goal of every GIS software is to prepare useful knowledge what is, where, and when. So where is it museum in the city? How can I get to a railway station and some another questions. Geographic and geospatial are synonyms, and most uh, scientists, most professionals in the GIS or geomatics infrastructure say that GIS is kind of three approaches. We can distinguish three approaches to GIS. First of all, the technology, uh, GIS as geographic information science, kind of concepts and theory, and uh, third approach, kind of application or data, mm, making decisions, help people to make proper decisions in everyday life, in military aspect, in environmental protection, and so on and so on. Here you can see Chinese proverb, um, and it can explain some aspects of maps and modern maps in GIS environment. Tell me I forget, show me I remember, involve me I understand. So uh, the main idea of every map and every modern GIS software mm, help people to remember, help people to understand. So we use GIS to convey spatial and tabular information through thematic layers, themes, or coverages. Uh, you can imagine our planet, the Earth, as kind of P with different levels. lithosphere, atmosphere, hydrosphere, biosphere, and noosphere. In all this imagination of our planet help us to analyze data, to understand how does um, our planet lives, how it works, and understand all the processes in the natural and human environment. Well, we can use GIS for make queries and quickly find useful data for your research, for your decision. We can combine different data sets and generate new thematic maps and generate new knowledge about natural environment. GIS allows to use different logical and mathematical operators and providing enhanced modeling capabilities of spatial analysis. GIS began to develop from maybe 1980s in the 20th century, and the main background of the GIS development are remote sensing. It's acquiring data from different remote sensors, from drones, aircrafts, and mainly from spacecrafts from outer space. We use different wavelengths uh, and different type of signals to get the information about the Earth's surface. Um, well, at the last quarter of the 20th century, the computer revolution mm, took place, and all the data that we must put on a map. Nowadays, we use digital data instead of analog data. Um, can anybody explain the difference between analog data and digital data? Hmm? Is anybody here?
Yeah,
Yeah.
yeah.
Yes.
Yes.
Give me examples of analog data and digital data in your everyday life.
Telephone.
Is does it use digital or analog data?
Maybe digital.
Digital.
Well, it transforms analog data of your voice, put it into the digital signal, and transfer it through radio waves to another person, and then this person can understand. Well, probably you know the ancient technology of sound recording, uh, tape recording, magnetic tape they use for write down the information about voice and about songs, about um, every sound information. Nowadays, we use digital recorders instead. Much more examples, please. Nikita, Alexander.
About digital and analog data, yes?
Mm-hmm.
So I can uh, I can tell media gallery in telephone can be as example digital data. I think.
Okay. And
And
analog data, for example, books. Yeah,
oh yeah,
we have.
books, newspaper, um, and
Magazine.
some kind of advertisement, big boards, and etc. Maybe.
Well, we can digitalize paper books, have a copy, digital copy of the text, and put it inside computer environment. Well, so nowadays remote sensing is use of digital information about the Earth's surface that we get from different uh, sensors that are remotely stay remotely from the Earth's surface. Drones, aircrafts, spacecrafts, different sea ships that can remotely get data about the sea floor. Well, source of GIS is cartography. You probably know that cartography is the science, art, and technology of making maps. Uh, we can distinguish maybe two kind of maps: hard copy maps that printed on a paper or on a plastic or probably on your T-shirt. Um, we use traditional cartographic process. This static map shows the static information on the particular period of time, or sorry, particular moment of time. So this hard copy map, we cannot change it since they are a single printed presentation of selected spatial elements and locations capturing spatial events on the one instance in time. And another example is dynamic maps that derive from a database stored in a computer and are accessible for upgrade and change. Um, so nowadays we are speaking about computer assisted cartography and maybe 99% of all maps uh, are going through digital process. The main core idea of GIS is a spatial analysis. It's a fundamental principle of geographic inquiry. Um, this analysis can help us to understand links of differences or uniqueness of the physical, social, and social phenomena operating in our world. An operational approach in spatial analysis is to identify problems that deal with space and location throughout time. A GIS provides the necessary platform to perform spatial analysis and functions as a thread linking raw data to information and ultimately to knowledge which may be further employed and in its decision-making capacity. So probably we use Google Earth or Google Maps first of all for decision-making process. All here you can see 5 kind of analysis predicated around the following basis questions. What? The object. Where? The location of the object. When? The time of the phenomena. How? The process, and why? The explanation. The last one, in my opinion, is very interesting because you probably know ancient Greek geographer Herodot. He explains the ancient Egyptian civilization in the short sentence. The Egypt is a gift of Nile. You probably know the Nile River, and all the Egypt civilization is kind of depends on the water from the river, from the humus, from the ground for cereals production in the area. Well, spatial analysis. GIS and spatial analysis is a result of cartography, remote sensing, and information technologies. Uh, well, the main activities that we can uh, make with GIS. First of all, communication. It means sharing ideas, beliefs in the computer environment. This communication in our life can be made, can be made in 3 ways. using spoken information by oral language exchange or articulacy. The written language exchange is often referred to as literacy, and symbolizing dealing with relationships among number sets, magnitudes, and abstractions is termed numeracy. So um, cartography allows to share uh, among people useful information about spatial phenomena about the Earth's surface. Then the forms of communications, literacy, articulacy, and graphicy. Uh, Someone says that uh, probably 80% of information about the world we get uh, using our eyes. So graphicy is very important. So geographic means making a graphical drawing of the Earth. Data we use numeric values or statistics, information word-based or graphic and derived from data elements through a process of source. So we in GIS creating process we distinguish data and information. First of all, we can speak about raw data uh, that we can get from sensors, and the information is interpretation of this data. And while we process all this data and information, we understand and explain phenomena about our world as knowledge. Well, system is an ensemble of connected entities and activities which interact together as a functional unit. GIS is an automated system applied to geographic data. It is a system of software and hardware, and also spatial data and personal people. So spatial and tabular data may be input and stored uh, inside this GIS environment. A brief history. GIS is multi-layered spatial display mechanism. It was explanation of GIS in 1969. We see computer assist technique emerge and begin to advance, dominated by landscape architecture, urban and regional planning, geography, cartography, remote sensing. And after 1990s, scientists began to speak about alliances with computer sciences, communicational geometry, computer graphics, database theory. Nowadays, the main highway of data exchange is World Wide Web. Um, Here in the picture you can see Roger Tomlinson. Um, uh, he often is called as father of GIS. He was Canadian geographer from Canada, and he was one of the foundators of National Canadian GIS system. He was working for Natural Resources Canada, and the book that is must have for you is Thinking About GIS by Roger Tomlinson. I will share with you English and Russian PDF of the book. So Roger Tomlinson defined GIS as a common ground between information processing and the many fields using spatial analysis techniques. Uh, Here in the slide you can see another definitions. A powerful set of tools for collecting, storing, retrieving, transforming and displaying spatial data from the real world. A computerized database management system for the capture, storage, retrieval, analysis, and display of spatial data. A decision support system involving the integration of spatially referenced data in a problem-solving environment, and so on. We have really huge amount of definitions, of GIS definitions. Well, what are the main parts of GIS? In the book by Roger Tomlinson, you can see a different kind of spatial data, which are hard copy of analog maps, uh, and also digital information from space satellites, from different sensors, from temperature sensors, humidity sensors, and another sensors, also statistic data. All the data are storage inside GIS environment, um, in the form of a spatial database. The core idea, the core of every GIS is spatial analysis. It's kind of getting new knowledge from different sources of data. And at this stage, we lose money. And so we just understand that we can pay all these technicians, scientists who will operate with spatial data, and for every factory, every plant, every organization, they must spend money for GIS creation and operating. And then at the last stage of informational products or informational services, uh, we must return our investment. It can be a kind of hard copy maps, graphs, schemas, and digital products such as uh, services via World Wide Web, via smartphones, etc. Here you can see another uh, point of view on GIS. Uh, you can see the link on GIS Long. It's a kind of digital magazine that is devoted to GIS science. And you can see concentric rings show the proposed components of GIS as well as some examples of what they define. In the center of the rings, it's geographic core ideas. It's kind of world mm, operates. Uh, this can be laws of distribution uh, by Vayekov, zones, altitude zones, uh, Zipf's law, etc., etc., etc. So it's understanding some concepts that explain how our world operates. Uh, the yellow ring is technology. It means how can we get and operate with necessary data. It's different bunch of technologies, for example, GIS software, programming, web design, database administration, systems administrations, uh, field work, data capture with different sensors, etc. Another green ring is data, and uh, all this core zone helps different specialty fields. For example, forestry, emergency management, hydrology, utilities, surveying engineering, demographic and census, transportation, geology, health, homeland security, military, urban planning, etc. These specialty fields we can work out different procedures or methods to help staff in these fields to solve their problems by using spatial data. And the main idea, the main technology is geovisualization of the process of information modeling and the result of geoinformation modeling. So, for example, you have 5 or 10 different maps, and then after manipulating the data, you can get another one, new map that explains some spatial peculiarities, some spatial laws, some spatial distributions. So here is comparing of current components of GIS and future proposed components. And for me, as for geographer, geographic core ideas in the middle, in the center of the GIS concept is relevant for me. Then the very important is the collaboration between different people, geographers or GIS specialists, and uh, different special fields. For example, ecologists, uh, geologists, uh, military, or army, and other specialists, and they together can uh, understand how can we use GIS in these different fields. Hardware and software, the combination of hardware and software we should call technology. This technology use spatial data, and then we use different methods and procedures to get our result, geo-visualization of our data. Not just data, but our ideas about the data. One of the famous American geographers, Michael Demers, he published this yellow and black covered book, GIS for Dummies. You probably know this series of books, Word for Dummies, Trading for Dummies, etc. So in this book, he explains uh, how one can easy understand what does GIS means and how does it works. We can make a break right now and let us continue in 15 minutes.
Okay.